Hey everyone, in this video we are going to talk about how to determine the domain and range of a function. The functions are typically going to be radical functions, so they usually start from a certain number and then go up and right. It's going to be a curve like this right here is a typical behavior of a radical function. That point can be any point on the coordinate plane depending on the function we have, but the behavior is going to be like this usually. It could be like that as well, or like this, but this right here is the most common way of graphing a radical function. If you multiply it by a negative number, it'll be flipped depending on the numbers added, subtracted. The starting point is going to change, but that's how these are the options you have for a radical function. So let's get started with this first question. What is the range of this function? So we need to know what domain and range is. Domain is right here, the x values, as you may know, and then range is the y values. So the vertical movement tells you what you have for the range of your function. So looking at the graph we have, we only need to focus on the blue curve. So if it has an endpoint or a starting point, those are going to tell me the vertical movement. So I see a point, just one point, which is this right here. That's called the starting point of the curve. And then the curve goes on forever to the right and up. It goes on forever. So as we go to the right, there's nothing that stops my function. So it'll go on forever to the right and up. So that means, again, since I'm just talking about the range, I don't need to know anything about the horizontal movement, which is the domain. I don't need to know how far this one goes to the right or left. That's not my problem for this question. My problem is if it goes down forever or up forever. So looking at here, it doesn't go down forever. It just stops at 0. So range is all about the y value. So my answer is going to have the letter y, okay? And it's not going to get any smaller than 0. I see that on the graph. It's the smallest value that it can get is 0. So it could be, let's just make a list. Can it be 1? So if I go to 1 on the coordinate plane on the y axis, so it has a corresponding point on the graph. Or like right here, y could be 7 because from y could be 6 because from 6 to the graph, we can just find another point on the curve. And then again, if you think about what I just said, it goes on forever up. Even though when I just do this from point 8 on the y-axis, it looks like they don't meet, but they will meet because this arrow means it'll go forever to the right and up. Even though it'll take time, they will meet at here. And if you extend this, they'll meet at 9, and if you keep extending it, they will meet at any point that goes up, because technically that graph goes up and right forever. So it could be 0, 1, and then infinity. This is just the range. We are just talking about up and down movement. So what that means, y values are going to be greater than or equal to 0. Because this one is a filled in circle, that means the point is included. So that 0 is going to be included. If I scroll down and see which one, so the third one is going to be my answer right here. Let's clear this and then give you another example. If it was like this, and then the graph would go on forever up and right, so the answer would be y is greater than 0. 0 would not be included if you have an empty circle at your starting point. So that's one of the details that you want to pay attention. So let's just submit it and then move on. Okay. Come on. So the second question, I just clicked another link. Let's get back. Okay, so with this one, come on. Okay, this one here is about the domain. We are talking about horizontal movement. That's the first thing you need to identify. Are you talking about the horizontal change or vertical change? So since this is the domain, it is about the x values that the green graph can take. So x values are over here. We are talking about the horizontal movement. So now just see if there's anything that limits your graph from going left or from going right. So the points are your boundaries. That's what you need to pay attention first. See if you have any points on the ends. So there is a point over here. So that stops the graph from going above that point up beyond that 9. But we don't care about it because this question is not about the range. And it also stops the graph from going to the left. Like if this is our boundary at that point, it's not going to go any further to the left from -7. So -7 is the smallest that this green curve can get. So my answer on the x-axis cannot get any smaller than -7, but it can get it bigger than -7. Like these numbers on the x-axis, it'll be like this, the graph, and then all of these numbers will have a part of the graph corresponding to them. Like here, that point, from 10 to the graph, from like 15 to that curve, we can keep finding points because the arrow on the other end indicates that it goes on forever to the right and down. For this question, we don't care if it goes down forever, but we do care if it goes to the right forever. So that means if it cannot get any smaller than -7, but it can go up to infinity, that would be my answer. So right here, let's clear this up, submit it. And then move on. Range is all about up and down. See what limits your graph. From going up, this point is my limitation. It's not gonna, like, any of these points are not part of the graph. So it can be 5, it could be 4, 3, and then down forever. I know it is down forever because this arrow has 2 directions, down and left. It'll go left forever and down forever. So if it goes on forever, don't worry about it. Just see your limitations, see your boundaries. 5 is my boundary for the y value. So y cannot be any bigger than 5, but it can be smaller than 5. It could also be equal to 5 as well, so that would be my answer. Y is less than or equal to +5. So that's how you complete this assignment. Let me just skip a level and see if it get any harder. The only thing that I can come up with is if they ask you the domain and range together in one question. That could be how hard this could get. Yeah, like this. Okay, let's do this one as well. So let's first start with the domain. Domain is the horizontal movement. That is a point. It's gonna stop my graph going to the left any more than that point. So it could be -2. I'm looking at all of these because that arrow indicates right and up. So the graph goes on forever up. It goes on forever and to the right. So these two directions are forever. And then they'll stop at -2. That's the other thing. And 0. So let's start with the domain. You're talking about right and left, right? This will go forever to the right. It's not going to go forever to the left. It'll stop at -2. So domain is all about the x values. It could be -2, but not any less than -2. X should be greater than or equal to -2 because that's a filled-in circle. -2 is going to be included. For the range, I'm just focusing on the y values, up and down movement. Now, what I want to do, let's just clear this up for now. Okay, so now we are focusing on up and down movement. There's a point. It's not going to go any further down from that point, but it'll go up forever because of this arrow indicating going up and right. So I have no problem with like big numbers. There's a limitation with the smaller numbers. So now that number is not going to be -2. You got to pay attention to that. You're talking about vertical movement, right? Up and down. So when you're just focusing on these numbers, that's 2 at this point. This right here is 0 level. It's not going to go beyond 0 because this right here is the 0 level for the vertical movement, and -1 is not part of that blue graph. -2 is not part of that blue graph. Anything beyond 0 is not part of that blue graph. So my boundary is 0. For the range, y is going to be greater than or equal to 0. This is what I'm looking at. X is greater than or equal to -2. Y is greater than or equal to 0. This right here. So we submit it and move on. So that's the only thing that might be confusing when you decide the domain and range altogether. Let's do one more. I'll skip one more level. Okay, good question. What is the range of this function? Range is the y values. So with these sort of questions, while you're going to be at 72, which is going to give you a +10. If you reach to 70, you'll get +10. You don't need to do these if you're okay with a B, but here's how you do it. Not hard at all. So range means what's the y value? Possible y values, not just one y value. So the possible outcomes of this function on the right side is the exact outcome is this, but what values can this get? So the answer is going to be, the answer is going to depend on this right here, because -8 is just a set number. So that's not the problem. The problem is the part that you have the variable. So whatever your variable belongs to, in this case it belongs to a radical function, and I think all of them are going to belong to a radical function because of the topic of the assignment. So what you need to know about the radical functions, they cannot get a negative value. They should be 0 or greater. Again, this is when you talk about the range. So when you're talking about the finite value of the function, on the left side I have the y. So the question basically is, what could your y values be equal to? It could be equal to whatever that orange block that I rectangled -8. So that orange block conceptually cannot be anything less than 0. It could be 0, it could be 1, 2, 3, and forever. Again, if you have a square root expression, just draw a rectangle around it and then know that it cannot be less than 0. It could be 0, 1, and forever. It goes on forever. So I don't care any of these numbers. I'm concerned about the boundary. That's how I will set up my answer. So the boundary is that 0. It's not go any further than this. That's the smallest. So if that's the smallest that it can get, again, we are focusing on the boundaries only. We don't care if 4 is a value that I can plug it in. I'm just concerned about the boundary because all of these are supposed to be the boundaries, but only one of them is right. So let's figure that boundary out. So since this 0 is my boundary, I plug it in for the block that I rectangled. So that 0 goes for square root expression and then -8. -8 was there, I just dropped it down. And then equals and y. I just rewrote my function, or equation in this case. So y equals 0 minus -8. So my boundary would be y equals -8. So that should be part of my answer, and there's only one that has that number. So that would be the range of the function. So let's do one more to make sense out of this. Again, we are concerned about the boundary, and the boundary is going to come out of the part that has the variable, that has the x. So this question is again about the range, and then it all depends on that expression, square root of x plus or minus 4. I don't see, yeah, minus 4. It's because you can plug in any number for x. That's the reason that it belongs to that expression, because there's part of it is a variable and it could be any number. So now we are concerned about this. What values can this get? The smallest is what you're concerned with, because it's going to go on forever. That square root expression, by definition, could be 0, 1, 2, 3, 4, and so on. So the boundary is, again, what I am concerned with, so I plug it in. Rewrite that whole function. Y equals 0 is the smallest. I'm just concerned about the boundary to figure that number out. Okay? So 0 is what we plug in, always, if we have a square root function and trying to figure out the range. Plus 5. So 5 is going to be part of my answer. So it's not this right here or that one. But which one is it? Is it going to be greater than 5 or less than, smaller than 5? So again, because of the same reasoning I told you, you can plug in 0, 1, 2, 3. You can plug in all those big numbers. So the answer is going to get bigger, which is why it is going to be greater than or equal to positive 5, not less than or equal to, because we can plug in all those positive numbers greater than 0. Okay, so here's one example, one more, to show you why it is greater. Instead of 0, you can plug in 1, and then in that case you would add 5. The answer would be 6, which is greater than 5. It should be greater than, your answer should be greater than or equal to 5. That square root expression could have been 4. In that case, when you add 5, your answer would be 9, which still should be greater than 5. So yeah, that was it for this assignment, guys. Thanks for watching. Let me know if you need any help with IXL Algebra 2 M12 to figure out domain and range of a radical function. Thanks again, and I will see you in another video.